Hello friends, myself Aher DR from RBNB College Srirampur. In last lecture, we study rotational dynamics. In that, we consider uniform circular motion and its applications. Now, in today's lecture, we have to study the vertical circular motion. As you know that there are two types of circular motion, uniform circular motion and non-uniform circular motion. In case of uniform circular motion, the motion of body along the circumference of a circle with constant linear speed is called as uniform circular motion. In case of non-uniform circular motion, the motion of body along the circumference of circle with variable linear speed is called as non-uniform circular motion. Now, today we study about the non-uniform circular motion. According to definition of non-uniform circular motion, the motion of body along the circumference is variable with linear speed. Now, in case of vertical circular motion, what is vertical circular motion? The circular motion of body which is vertical to the surface of earth is simply called as vertical circular motion. There is another type of circular motion, that is horizontal circular motion. In case of horizontal circular motion, we know that the circular motion of body is horizontal to the surface of earth. That's why it is called as horizontal circular motion. For a non-uniform circular motion, we have to study the vertical circular motion. This is circular motion of a body which is vertical to the surface of earth, and that's why it is called as vertical circular motion. This vertical circular motion is of two types. A controlled vertical circular motion by the giant wheel, and another type of vertical circular motion is a vertical circular motion which is controlled by only gravity. Now, in this lecture, we have to study only the vertical circular motion which is controlled by only gravity. So, in this case, we consider a point mass, and that point mass is attached to the one end of the thin inextensible string, and this string is revolved in a vertical circular motion. And then under the gravity we have to find out the minimum velocities at lower position, upper position and midway position. So first of all we have to consider the vertical circular motion, and in that case we consider point mass. That point mass is revolving in a vertical circle. So as like this diagram, O is the center of circle, and a point mass or particle which having mass say small m. So this is the m, small m is the mass of object which is revolving along the circumference of a circle in an anti-clockwise sense in a vertical circular motion. Particle of mass m revolving along the circumference of a vertical circular motion in anti-clockwise sense. Now, when particle is at position A, then we know that in case of vertical circular motion, velocity at different point along the circumference are different in magnitude as well as direction. So when we consider particle is at A, then its velocity is small and its velocity is given by Va. Now when particle moving from A to this position B, then what happen? Its potential energy continuously goes on decreasing and kinetic energy goes on increasing. So when particle is at A position, then what happen? When it revolving along the vertical circular motion, then there is change in the potential energy, and this change in the potential energy is equal to the change in the kinetic energy. Means one energy goes on decreasing while another energy goes on increasing. So while particle moving from A to B along the circumference of circle in vertical circular motion, then potential energy continuously goes on decreasing and kinetic energy goes on increasing. Now when this particle moving from B to A, then velocity continuously goes on decreasing when particle moving along the circumference of circle in vertical circular motion. So kinetic energy goes on decreasing. As kinetic energy goes on decreasing, potential energy goes on increasing. So at position A, potential energy is maximum. At position B, kinetic energy is maximum. So when particle is at position B and its kinetic energy is maximum, therefore velocity at B is maximum. If you consider midway point, say this point C and this point D. Now when particle moving from A to B, then velocity is along the tangent, so Vc is the corresponding velocity. Now its magnitude is greater than Va but less than Vb. As we know that when particle moving from A to B, velocity continuously goes on increasing, therefore kinetic energy also goes on increasing and potential energy goes on decreasing. At position A, remember that its potential energy is maximum. At position B, kinetic energy is maximum. Now this velocity at point C and velocity at point D both are having equal magnitude. Both are having equal magnitude. So this is the velocity D. Now we have to find out velocity of a particle when it is at A, and also we have to find out when particle is at B, then we have to find out minimum velocity of that particle, that is Vb. Then also we have to find out velocity of particle when it is at C point or D point, means we have to find out magnitude of Vc and Vd. For that purpose, we can consider a particle of mass, or small m is the mass of that object. Small r is the radius of the circle. Ta is the tension in the string. When object is at position A. Similarly, when particle is at position B or object is at position B, then Tb is the tension in the string when object is at position B. Similarly, Tc and Td both are same. These are the tension along the string when object is at position C or D. Now in case of tension, remember that all these tensions are lies along the string and always it is directed toward the center. Now when we consider particle is at point A, then tension in the string is along the string directed toward the center of a circle, which is given by TA. So TA is the tension in the string when particle is at position A. Similarly, when particle is at position B, then tension in the string is TB, which is along the string directed toward the center. Now when particle is at position C or D, then tension in the string is TC along the string directed toward the center. So from this we can say that, always remember that this tension is along the string directed toward the center in case of vertical circular motion. Now we have to find out the magnitude of TA. When we consider mass of object is small m, then g is the acceleration due to gravity acting on that mass, so weight of that bob or weight of that object, that is equal to m into g. Weight of that object is mg. Now when object is at position A, then its weight is acting vertically downward direction. So at this position mg is vertically downward direction. Now when particle or object is at position B, then its weight is downward direction. Always remember that weight of object is in vertical downward direction. So when it is at the C, then weight is downward direction, mg. When it is at point D, weight of the object in a downward direction. As like tension is always along the string directed toward the center. Similarly, we can say that weight of the object is always vertically downward direction. Now consider when particle is at position A. When object is at A, position A. Now this tension at point A and mg both are along the string directed in downward direction, and that's why we take TA plus mg, both having same direction, so we take here plus sign. And we know that for circular motion there is a necessary centripetal force. Now when particle is at position A, then magnitude of centripetal force is mva square upon r, where m is mass of the object, va is corresponding velocity when particle is at position A, and r is the radius of the circle. In that case radius always remains constant, really radius of circle always remains constant. So we write here small r is the radius of the circle. Small r is the radius of the circle. So in this way, when particle or when object is at position A, then TA plus mg is equal to centripetal force mva square upon r. Now by rearranging this equation, we get tension along the string at position A is equal to, now this mg here plus, on that side will be become minus mg. So we get mva square upon r minus mg. Equation first. Now this equation first gives us tension along the string when particle is at position A. So in this way we get TA, tension along the string when object is at position A. Similarly, when object is at position B, then tension is along the string in upward direction, but weight of the object is in a downward direction. So we write TB minus mg, both are having opposite direction. Again in that case, due to the centripetal force, there is vertical circular motion, and therefore necessary centripetal force provided is mvb square upon r. In that case, m is mass of the object, vb is the corresponding velocity of object when it is at position B, and r is the radius. Now by rearranging this equation, we get tension along the string at position B, TB is equal to, now here mg is minus, on that side it will become plus, so we get mvb square upon r plus mg. This is equation 2. In this way, we get tension at position A and tension at position B. Now, when particle is or when object is at position A, then we have to find out its minimum velocity VA. So, when particle is at position or object is at position A, then tension in the string is equal to 0. The tension in the string is equal to 0. But particle revolving along the circumference of circle in vertical circular motion. Now when we substitute TA is equal to 0 in equation 1, then we get zero equal to, because we know that TA is equal to 0, so 0 equal to mva square upon r minus mg. Now again this minus mg on that side will become plus, so we write mva square upon r, that is equal to mg. This get cancel because it is mass of the object, get cancel, and we get va square is equal to, by rearranging this one, now r is in downward direction, so in that case it is multiplied, so we get va square is equal to rg, and by taking square root we get velocity of an object at position A is equal to under root rg. This is the minimum velocity of a particle when particle is at position A. So in this way we find out magnitude of VA, and magnitude of VA is equal to under root RG. So in this way we get minimum velocity of a particle when particle is at position A, that is equal to under root RG. Now we have to find out magnitude of velocity of an object when object is at position B. So in that case we know that as particle moves along the circumference of a circle from A to B, then its potential energy continuously goes on decreasing and kinetic energy goes on increasing. So during the motion of object from A to B, we can say that change in a potential energy, that is equal to change in a kinetic energy. change in potential energy is equal to change in kinetic energy. Now we know the formula for potential energy. Potential energy is equal to mgh, where m is mass of an object, g is the acceleration due to gravity, and h is height. Now when we consider this motion of an object from A to B, so initial position of object is say at position A. Now this distance is r, so at the center this distance is r. Now lower position at distance say B, this total distance is small r, so r plus r, that is equal to, this distance is twice r, that distance is twice r, means in that case h is equal to twice r. Now when particle is or when object is at position A, then its kinetic energy is half mva square. When particle is at position B, then its kinetic energy is half mvb square. Now we have to find out change in the kinetic energy. So change in kinetic energy is equal to half mvb square minus half mva square. So we write here change in the potential energy is equal to mgh equal to change in kinetic energy is half mvb square minus half mva square. Now in that case we know that this distance is r plus r, that is equal to twice r. So here we substitute h equal to twice r. Here we substitute h is equal to twice r. Then we get mg into twice r, that is equal to. Now in this case we take common half into m. So remaining is in bracket Vb square minus Va square, that is equal to mg into twice r. Now here get cancel. Now these two on upward side will become multiplied, and so we get 2 into 2 Rg, that is equal to Vb square minus Va square. So 2 into 2 will become 4. So we write here Vb square minus Va square, that is equal to 4Rg. But we know the value of Va square. In that case we know Va square is equal to only Rg. So by using this value, this equation will become Vb square, that is equal to, now this Va square on that side is negative, on other side it will become plus, so we get 4Rg plus Va square, and we substitute value of Va square is equal to Rg, so we get Vb square is equal to 4Rg plus Rg, so 4Rg plus Rg means 5Rg. So in this way we get Vb square is equal to 5Rg, and by taking square root of both sides we get Vb is equal to under root 5Rg. So this is the equation 4. Now this equation 4 gives us the magnitude of velocity of an object at position B, and it is maximum as compared to the Va. So we write Vb is equal to under root 5Rg. Vb is equal to under root 5Rg. So we know that the velocity at point A is minimum and velocity at point B is maximum, and that's why it is called as vertical circular motion, because its velocity continuously goes on changing. Now we have to find out the magnitude of velocity at point D and velocity at point C. So for that purpose, again we know that when object moving from A to C, its potential energy continuously goes on decreasing and kinetic energy goes on increasing. Similarly, when particle is at position B and when it moving along the circumference toward D, then its kinetic energy goes on decreasing, potential energy goes on increasing. So we have to find out velocity of particle at point C and at point D. So velocity at point C or D. Change in potential energy is equal to change in kinetic energy. Now we know the formula for potential energy is again mgh, change in kinetic energy. So for change in the kinetic energy, when particle or object moving from A to C, then kinetic energy at point A is half mva square and kinetic energy at point C is half mvc square. So change in kinetic energy will be half mvc square minus half mva square. So we write directly here, change in kinetic energy is half mvc square minus half mva square. Now in that case, as particle or body moving along or particle or object moving from A to C along the circumference, then this distance is equal to only r, means this distance is only r. So in that case, value of h is equal to only r. So we substitute h is equal to small r. Then this equation will become mg into r, that is equal to half m, by taking it common, remaining is in bracket vc square minus va square. Now again get cancel, so we get vc square minus va square, that is equal to 2 into rg. Now we have to substitute value of va square is equal to under root rg. So we get vc square is equal to 2rg plus va square, and we have to substitute value of va square is equal to rg. So we get vc square is equal to 2rg plus rg, that is equal to 3rg. And by taking common, we get by taking square root of both sides, we get vc is equal to under root 3rg. Vc is equal to under root 3rg, equation 5. Now in this way we get magnitude of Vc, and magnitude of Vc is equal to under root 3rg. But we know that the minimum value of an object revolving along the circumference of circle, when it is at point C, then Vc is equal to under root 3rg. Also Vc is equal to Vd, therefore magnitude of Vd is also equal to under root 3rg. So in this way we get velocity of an object revolving along the vertical circular motion. At position A, velocity is minimum. At position B, velocity is maximum. So we get Va, Vc and Vb. Now we have to find out difference in the tension. Difference in the tension. For that purpose, we consider this equation 1 and equation 2. We consider only equation 1 and equation 2. So for difference in the tension, we consider when particle is at position A, then corresponding tension is TA. And when particle is at position B, then corresponding tension is TB. Now we have to take difference between them. So we get TB minus TA. That is equal to, equation 1 gives us TA and equation 2 gives us TB. TB is equal to mVb square upon R plus mg, and TA is mVa square upon R minus mg. So TA is minus, so minus mVa square upon R. Minus will become plus, so plus mg, that is equal to, now m upon r, in both these two terms we take common m upon r, remaining is in bracket Vb square minus Va square plus mg is twice mg. mg plus mg is twice mg. Now this is equal to TB minus TA. So that is equal to m upon r in bracket Vb square minus Va square plus twice mg. We get value of Vb square. Vb square is 5rg. So we write m upon r in bracket Vb square is 5rg. Va square is only rg plus twice mg as it is. So that is equal to TB minus TA equal to m upon r, 5rg minus rg, that is equal to 4rg in bracket plus twice mg as it is. Now this r and this r get cancelled. So we get TB minus TA, that is equal to 4 mg plus this remaining twice mg. So finally we get TB minus TA, that is equal to 6 mg, equation 6. Now this equation 6 gives us the difference in the tension at two different positions. Here we take tension when object is at position A and TB when object is at position B. So we get TB minus TA, that is equal to 6 mg. So in this way we study the point mass undergoing vertical circular motion under the gravity. Now in next lecture we consider a point mass undergoing vertical circular motion which is connected to the one end of the rigid rod. So today we stop here. Thank you.